Virtualization has been around for years. As enterprises sought more control over their networks, they started applying virtualization principles to their data centers and eventually to the wide area network, or WAN, and local area network, LAN. Network virtualization lets enterprises scale their networks by adding centralized control and applying specific security policies to workloads and traffic types. This all helps the network deliver applications and services more quickly. Here, we'll go over the basics of network virtualization, like how it works, the types, and the benefits and challenges of virtualization. For a deeper dive, explore our complete collection on all things network virtualization by clicking the link above or in the description below. Network virtualization combines the available resources in a network to consolidate multiple physical networks, divide a network into segments, or create software networks between virtual machines. It abstracts and isolates network applications and services from the underlying network hardware devices and physical infrastructure. Teams managing the network can add and scale these virtual networks without making any changes to the physical hardware. Because network virtualization doesn't require admins to manually configure hardware, teams can spin up logical networks as the business requires them. This flexibility enables faster service delivery, operational efficiency, and improved control. Some of the first forms of network virtualization were virtual private networks, or VPNs, and virtual LANs. As virtualization use cases extended throughout the network, enterprises eventually adopted software-defined networking principles that applied virtualization to their data centers, WANs, and elsewhere. Meanwhile, telecommunications carriers use feature virtualization and network virtualization to deliver services efficiently to enterprise customers. With feature virtualization, the carrier's strategy focuses on network functions virtualization, or NFV architecture. NFV removes individual functions like load balancing, routing, and firewalling from dedicated hardware devices and hosts them on virtual appliances or commodity hardware. This allows carriers to load specific feature software onto general-purpose equipment and deliver the services as virtual network functions, or VNFs. If carriers want to expand their portfolios, they can develop new software instead of buying specialized hardware. Some common network virtualization use cases include performance management and security and risk management. For example, network virtualization helps network teams allocate appropriate bandwidth for specific resources, while also specifying and enforcing security policies to meet auditing requirements. But how exactly does the network team virtualize a network? The process typically involves network components like a network hypervisor, controller software, host protocols, virtual switching and routing, and management tools. The key component of abstracting network services from the physical infrastructure is the network hypervisor. A hypervisor is a function that isolates operating systems and applications from the underlying computer hardware. The hypervisor lets administrators create, provision, and manage virtual networks through software. Admins can choose to either establish network virtualization operations manually or implement them via orchestration and automation mechanisms. The latter allows for automated creation and control of virtual networks. The hypervisor controls the resources, bandwidth, and capacity for each logical network. While the virtual networks share the hypervisor platform, they remain independent of each other. They even have their own security rules. Elements within a virtual network can communicate with each other and with nodes on a separate virtual network, using encapsulated host protocols, virtual switches, and virtual routers. The messages don't travel through the physical networking devices, which helps reduce latency. Network administrators can migrate a workload from one virtual network host to another in real time, with the associated security policies and networking requirements moving with it. The virtualization platform also applies security policies to new workloads automatically. Traditionally, virtual networks exist in two forms, external and internal. These two terms refer to their location in relation to the server. External virtualization uses switches, adapters, or networks to combine one or more networks into virtual units. Internal virtualization uses network-like functionality in software containers on a single network server, so virtual machines can exchange data on a host without using an external network. Network virtualization initiatives are typically identified by their uses within different segments of the network, such as the data center, WAN, or LAN. These segments are often managed by different teams and focus on different use cases. As networking evolves, though, enterprises may need to consider how to consolidate these individual initiatives if they want to attain an end-to-end network virtualization strategy with embedded zero-trust security. It's probably no surprise that security must be central to any network design. But with different areas of the network typically isolated from one another, it can be difficult for network teams to create and enforce security policies across the whole network. Taking a zero-trust approach to network security can unify those network segments and their associated virtualization initiatives. The zero-trust framework relies on user and device authentication throughout the network. For instance, if users on a LAN want to access data center resources, they must receive authentication to do so. A zero-trust environment, combined with network virtualization, provides the secure connectivity needed for endpoints to converse securely. Virtual networks can be spun up or down to support these interactions, while maintaining the necessary level of traffic segmentation. But to ensure the security in the network, it's essential to specify access policies that detail which devices can talk to each other and where. For example, if a device is permitted to reach a data center resource, the policy must also be set at the WAN and campus levels. This is one of the biggest challenges for network teams because it can be difficult to determine which entities need to talk to each other. There's a human challenge here, and that's getting teams to work together. Network and security teams need to discuss security policies, network requirements, and infrastructure upgrades together. Before we dive into the challenges of network virtualization, let's look at some of the benefits. The benefits vary based on the business and where enterprises implement it within their networks. For example, virtualization within the data center can support scalability and enhance security through microsegmentation. WAN virtualization, on the other hand, focuses more on improving application performance and policy enforcement. Overall, the most common benefits of network virtualization include greater operational efficiency, faster application delivery, better network security and disaster recovery, faster network provisioning and configuration, and hardware cost savings. While there are clear benefits to network virtualization, it does come with its challenges. One challenge is virtual sprawl. Because it's so easy to create virtual networks, virtual sprawl happens when admins create more virtual networks than they can manage or keep track of. Not surprising, this often results in excess resource consumption and network complexity. Another challenge is managing the effects of network architecture changes. As enterprises migrate from physical appliances to virtual networking, they need to calculate how the new architecture might affect their resource consumption, such as CPU and storage. A change in network architecture can also affect resilience and security. Knowledge silos are another potential headache. Traditional IT teams are usually siloed into different departments, such as security, networking, and servers. The spread of virtualization throughout various parts of the network, though, makes collaboration among these separate departments essential. One of the cultural challenges is the need for IT staff to quickly acquire new skills. Because of traditional IT and network silos, there's going to be a learning curve as IT staff gain the skills they need to configure, manage, and operate various network virtualization technologies. Then there's the issue of traditional monitoring tools losing visibility into the abstracted layers of the virtual network. To counter this, network teams might adopt more network visibility tools, but that adds to the sort of tool sprawl that's common among enterprise networks. Finally, there's the challenge that comes with automation and AI. Network virtualization sometimes introduces automation and AI tools to the network. These tools improve network management, but they also require new standards and processes that need to be documented. Network teams must take care that automation and AI strategies align with each other. Despite the challenges, the reality is network virtualization is here to stay. It will continue to be an important element in both enterprise and carrier network designs. Moving forward, expect to see network virtualization initiatives that include zero trust, automation, and edge and cloud computing.